Hi everybody, in this video, let's look at Form 4 Modern Math 9.3, Mutually Exclusive Event and Non-Mutually Exclusive Event. What does mutually exclusive event mean? Let's look at this example. Determine whether each of the following events are mutually exclusive event or non-mutually exclusive event. Given the sample space is integer, x is an integer, and x is greater than 20, less than 50. You need to be more careful here. You'll notice that the sign here, we don't have equal sign, right? So this means that 20 and 50 are not included. In other words, x is actually greater than or equal to 21, less than or equal to 49, and x is an integer. And the three events E, F, and G are defined as follows. Event E is the event of getting a prime number. Event F is the event of getting a number that is divisible by 7. Number that is divisible by 7 means that that is multiples of 7. G, a multiple of 3. Determine whether the following pair of events are mutually exclusive. Let's look at part 1 first. So before we determine whether the two given events here, they are mutually exclusive event or non-mutually exclusive event, let us write down the element for the set E, F, G, and also sample space. The sample space here actually contains a lot of elements. If the question does not request you to write all down, you don't have to write all down, it's okay. But here I'm going to list out all the elements for the sample space so that easier for me to explain to you. Okay, these are all the elements for the sample space from 21 to 49, actually an integer, so that we don't have to consider about the decimal fractions. Okay, we have set E, F, G. All the elements for E, F, and G must be taken out from the sample space. Let's look at E. Event E. Event of getting a prime number. So we know that the first prime number is actually 2, right? But we cannot write 2 because sample space does not contain the number 2. We have to choose from here. So we just choose from here. So it can be 23. First prime number here is 23. Then followed by 29, 31, 37, 41, 43, 47. Okay, let me write down all the elements within this range, all the prime number within this range first. 23, 29, 31, 37, 41, 43, and 47. Okay, now let's go to the second part, F. Number that is divisible by 7. In other words, we can say that multiple of 7. So we just choose from here. We cannot write 7, 14 because sample space does not have 7 and 14. Okay, it's 21, 28, 35, 42, and 49. Now let's go to the last one, set G, a multiple of 3. So same thing, we have to choose from here. We cannot write 3, 9, 12, all this number we cannot write it because sample space does not have that number. So we need to choose from here. Okay, so these are all the elements for set E, set F, and set G. Now we can start to determine whether set E and set F, this event E and event F, they are mutually exclusive or non-mutually exclusive. Let's look at E and F first. Let's focus on these two. Do these two sets have any common element? Let's look at 21 here. We don't have 21. 28 we don't have 28 over here. 35 no. 42 no. 49 no. So if I want to draw a Venn diagram to represent the set E, F, and S, okay. Now the question is asking about E and F, so we just forget about G first. Okay. Now, if I want to draw a Venn diagram to represent this sample space, event E and event F, it will be like this. E and F must be separated because they don't have any common element. So this is E, this is F. And we draw a rectangle outside to represent the sample space. Okay, sample space. Now in this situation, E and F does not have any overlapping area because they do not contain any common elements. So in this situation, we say that event E and event F, they are mutually exclusive event. Mutually exclusive event. So let's say if we want to find the probability of getting a prime number or getting a number that is divisible by 7, alright, so I will be using union. This is all. Okay, if you see the word used is all, then we use the symbol, the sign union. So in this situation, if we want to find the probability of that, it will just be P, probability of getting a prime number, plus the probability of getting a number that is divisible by 7. Okay, this formula is for mutually exclusive event. Now how about E and G? Now let's focus on E and G, forget about the F. Focus on E and G. 23, we don't have 23 over here. 29, no. 37, 31, 41. Okay, you will notice that E and G do not have any common element either, right? So when we want to represent it by using a Venn diagram, it will be the same thing like this one. First, let's draw two circles, but these two circles need to be separated because they don't have any common element. And then we draw a rectangle to represent the sample space. And this is E, and this is G. Same thing over here. Since that this E and G does not have any common element, therefore the E and G do not have any overlapping area. So we say that E and G, they are mutually exclusive event. Mutually exclusive event. If I want to find the probability of getting a prime number or a multiple of 3, since I use the word or, right? So it will be E union G, or. Okay, so it will be probability of getting a prime number plus the probability of getting a multiple of 3. Okay, now let's go to third part, F and G. Now let's focus on F and G. F and G will be this and this. 21. Oh, now this time they have common element 21, 21, 42, 42. Okay, so they have two common elements. Means that the 21 and 42 is a number which is divisible by 7. At the same time, they are a multiple of 3 as well. So satisfy this both conditions simultaneously. So when we draw or when we represent them by using a Venn diagram, the F and G, let me use this, F, G, they will have the overlapping area. So this is F, this is G. Okay, so let me draw a rectangle for the sample space. Okay, so in this situation, if I want you to find the property of getting a number which is divisible by 7 or a multiple of 3, still the same since I'm using the word or, F union G. This time the formula will be slightly different. It will be property of getting a number which is divisible by 7 plus the property of getting a multiple of 3 minus the property of getting a number that is divisible by 7 and the probability and getting a number which is a multiple of 3. Okay, so why do we need to minus that one? When we calculate the probability of getting a number that is divisible by 7, we calculated this part, right? Oh, this part. Okay, and plus probability of getting a multiple of 3, we calculate here. We consider this part. Now, you will notice that this part, we have added it for 2 times, right? Therefore, we need to minus it back. In this situation, we say that event F and event G, they are non-mutually exclusive event, non-mutually exclusive event. Okay, so this one, the two circles separated, they don't have any common element, mutually exclusive event. This one, the two circles, there are some overlapping area, they have some common elements, so non-mutually exclusive event. Okay, now let's try other example. Okay, just now I forgot to tell you that sometimes when the number, let's say it's quite big, so if you are not sure whether the number is a prime number or not a prime number, you actually can use your calculator to help you to check. Let me show you some example. 23 is, let me take some, not the number that is not a prime number to show you first. Let's say 21. 21 is not a prime number, right? So you just key in 21. You just key in 21. Press equal, then I'm going to use a prime factorization function of this calculator to help me to determine whether the number is a prime number or not a prime number. Okay, let me rekey in again. 21, press equal. Okay, shift prime factorization. Now, you will notice that the calculator changed the 21 become 3 times 7, right? If the calculator changes the way of writing 27, like this one, then we know that this number is not a prime number. Let me show other example. Let's say 24 equal, then we are going to do the prime factorization. 2 power 3 times 3. 24 is not a prime number. So if you key in a prime number, let's say 41 equal shift prime factorization, you will notice that the number does not change at all. So in this situation, we know that this is a prime number. Let me give you an example. For example, 47 equal shift prime factorization here. You notice that still we don't have any changes here. So therefore, we know that the 47 is actually a prime number. So this is a way how we test whether a number is a prime number or not a prime number using our calculator. Now, let's try other example. 2 dice are rolled one by one. Find the probability that the sum of the two numbers on the dice is 6 and so on. So in this situation, I would suggest you to draw a diagram to help you to get the answer. One dice, there are 6 possible outcomes, right? 1, 2, 3, 4, 5, 6. So I'm going to draw 6 vertical lines. 1, 2, 3, 4, 5, 6 to represent the 6 possible outcomes for the first dice. For the second dice, there are 6 possible outcomes as well. So this time I'm going to draw another 6 line, but this time go horizontally. 1, 2, 3, 4, 5, and 6. Okay, let me label it first. This is for the first dice. 1, 2, 3, 4, 5, 6. This is for the second dice. 1, 2, 3, 4, 5, 6. Total we have 36 pair of outcome. This is 6, here 6, here 6. 6 times 6, you will get 36. So these are all the possible outcomes. You just look at the intersection 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, and so on. There are 36 pair of possible outcomes. Okay, now let's go to part A. Find the probability that getting the two number, their sum of the two of their sum is equal to 6. Okay, so you can just refer to this diagram. It will help us to determine the answer. So their sum must be equal to 6, means that 1 need to pair with 5, right? If 2 need to pair with 4. 2 plus 4 will give you 6. 1 plus 5 will give you 6 as well. And 3 pair with 3, 4 pair with 2, 5 pair with 1. So 6, we cannot pair with 0 because dice does not have a 0 number. A number that's 0, dice only have 1 until 6, right? Okay, so the probability will be 1, 2, 3, 4, 5, 5 over 36. Let's go to the second part, part B. The difference between the two numbers on the dice is 3. Okay. So it can be 1 paired with 4, right? The first die show you 1, the second die show you 4. Their difference is 3. So it can be 2 paired with 5. 5 minus 2 will give you 3. 3 paired with 6. 4 paired with 1. If the first dice give you 4, second dice give you 1, their difference also 3, right? Okay, so 5 paired with 2, 6 paired with 3. So the probability will be 1, 2, 3, 4, 5, 6. 6 over 36. So if we simplify it, you will get 1 over 6. Okay, now let's go to the last one. The sum of the two numbers on the dice 6, you will notice that this is actually same with this one, right? Or, okay, let me use this, or. So all we know that this is, we use this sign, union. The difference between the two numbers on the dice 3, this part, is actually same with this part, right? So if this is event A, this is event B, the part C is actually asking us to find the probability of A union B, right? So you will notice that these two events, A and B, do not have any common element, right? They are mutually exclusive event. So for the last one, probability, you will just need to take this one plus this one, 5 over 36 plus, so I will be using this one because same denominator will be easier for me to calculate. So you will get 11 over 36. They are mutually exclusive, so we don't have to minus the probability of A intersection B. So let's say if you are not sure whether these two events, they are mutually exclusive or non-mutually exclusive, it's not a big problem, you still can do it. How do you do it? You just calculate this way. The sum on the two numbers, the sum of the two numbers on the dice is 6, the cross, the blue cross, and the difference between the two numbers on the dice is 3, green dot. So you just calculate all this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 over 36. You still can get the answer. Okay, so these two events, this and this, they are mutually exclusive events. So if you want to draw a Venn diagram to represent them, set A and set B, they will be separated. No any does not have any overlapping area. Now let's go to the last one. A fair dice and a coin are tossed simultaneously. Calculate the probability of obtaining a prime number from tossing of the dice. So same thing, let's draw a diagram to help us to visualize the situations. For dice, there are 6 possible outcomes. So I'm going to draw 6 vertical lines. 1, 2, 3, 4, 5, 6. For the coin, there are two possible outcomes, head or tails. Head or tails. Okay, let me label it. 1, 2, 3, 4, 5, 6. This is for dice, and this is for coin. Head or tail. This is for coin. Okay, let's look at part A. A prime number from tossing of the dice. So we don't have to focus on the coin, we only focus on the dice. A prime number. Okay, a prime number, the first prime number is actually 2, right? 1 is not a prime number. So it can be 2 paired with head or 2 paired with tail, as long as the dice give us a prime number. So it can be 3 paired with head and 3 paired with tails, 5 head, 5 tails. So the probability will be 1, 2, 3, 4, 5, 6, 6 over 12, right? You have 12 in the section point here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we simplify it, you will get 1 over 2. Okay, how about part B? A head from tossing of the coin. Now we forget about the dice, we only focus on the coin. As long as the coin gives us a head, then we'll accept it. So it can be this one, this, 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 and this. Okay, so the probability will be 1, 2, 3, 4, 5, 6. Again, 6 over 12, we simplify it, we will get 1 over 2. Now how about the last one? A prime number or a head? A prime number, which is exactly the same as this one, or a head exactly the same as this one. Now, the question is using or, so we know there's union, right? If I let this event be A, this event be B, so this will be A union B. So now if I ask you, is this the event A and B, they are mutually exclusive or non-mutually exclusive? You will notice that they have some common element, which means that they satisfy these both conditions simultaneously. So if I want to draw a Venn diagram to represent the situation here, the Venn diagram will be like this. This is a sample space, this is okay, A and B. They have some overlapping area. So this is non-mutually exclusive event. So for the part C, if you want to find the probability getting a prime number or a head, it will be this one plus this, but we need to minus P, probability of getting A intersection B. So what is the probability for this one? Overlapping area. So 1, 2, 3. You will notice that you have a cross and also highlighted as well, right? Means that this pair satisfy both conditions simultaneously. So we have three pair, 1, 2, 3. It will be 3 over 12. Okay, 3 over 12. Just press your calculator. So you should be able to get 9 over 12. If you simplify it, you will get 3 over 4. So these two events, they are non-mutually exclusive event. Let's say if you are not sure whether they are mutually exclusive event or non-mutually exclusive event, you still can get the answer. What you need to do, just calculate from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 over 12. And you simplify it, you still get the same answer, 3 over 4. Okay, that's all for this video. See you next time. Thanks for watching. Bye bye.